Dear students, welcome to Zoom online section class 9 subject physics. Today we are going to start a unit 8 thermal properties of matter and book page number 198. Introduction. Thermodynamics. The study of heat transformation into other forms of energy is called thermodynamics. Therms mean heat. Now we are going to start temperature introduction. Temperature is a concept we all understand from experience. Even a small child, we learn to perceive hotness and coldness of the object. We hear weather forecast tell us that the temperature will be 32 degrees Celsius today. We hear doctor tells us that our body temperature is 98.6 degree Fahrenheit. Temperature. What is the temperature? And the definition is to measure the degree of hotness or coldness of the body with respect to some standard is called temperature. Look at this diagram. This tells you the temperature of the sun and the different objects. Now the information is that the Death Valley, California, the hottest place on earth, the summer temperature reached to 56 degrees Celsius. The Antarctic, during the continuous darkness of midwinter, the temperature here can be as low as minus 87 degrees Celsius. Unit. The temperature is measured in degree Celsius, degree Fahrenheit and Kelvin means degree centigrade, degree Fahrenheit means Kelvin. These are the units of temperature. Now the space between these fixed points is broken up into a division called degrees. You are able to see these lines. These lines are called, these are divided, this stem is divided in degrees. Now kinetic molecular description. Here we will extend our understanding of temperature on the basis of kinetic molecular description. According to this theory, atoms and molecules are in continuous random motion. According to this theory, the temperature can also be defined as the average kinetic energy of molecules of a body is called a temperature. Look at this diagram. A temperature and heat. Number one, the temperature is related to the average kinetic energy of the particles of a substance. Look at this diagram and you are going to be clarified. Look at the second one diagram. The temperature is average kinetic energy, the hot fast and a cold slow. Now the internal energy and temperature definition. The internal energy is defined as, now what is the internal energy? The sum of kinetic and potential. We know that what is the potential? Storage energy. Kinetic and potential energy is associated with the motion of the atoms of the substance is called our internal energy. Now explanation. That example of gases. For example, in a gas made up of a single atoms, monoatomic gas, such as a helium, the atom moves around randomly, colliding with each other and with the walls of the container. So each atom has some translational kinetic energy. However, if the gas is made up of molecules with two or more atoms, the molecules can also stretch, contract and spin. So these molecules also have other types of kinetic energy called a vibrational and a rotational kinetic energy. Look at this one diagram, that our internal energy of gas, and the second one is a kinetic energy is directly proportional to the Kelvin temperature. Now example of liquid. If gas molecules in a liquid are free to move, but within the confines of the surface of the liquid, there is some attraction between molecules, which means there is some energy stored as a molecule approach each other. Now the examples of the solid. In a solid, atoms jungles vibrate rather than move around. They have kinetic energy, but they also have a lot of potential energy stored in the strong attractive force that holds the atoms together. So this kinetic and potential energy combinedly called internal energy. Look at this one diagram. The gas space is more as compared to the liquid, and the liquid space is more as compared to the solid. Internal energy and temperature. Temperature is a measure of the average kinetic energy of particles. The other contributions of the internal energy do not affect the temperature. The kinetic energy may be in the form of translational, vibrational, and the rotational kinetic energy. As the atom or molecules of the material are in constant motion, at high temperature, the kinetic energy of molecules is more and at lower temperature is less. As atom of molecules of the material are in constant motion, at high temperature, the kinetic energy of the molecules increases. The monatomic gas, a gas whose molecules have only a single atom, shows in figure each, which only have a translational kinetic energy. At high temperature, the increase in translational kinetic energy is observed. This means internal energy increases with increases temperature. So the internal energy equals to a kinetic plus potential energy. Look at this one diagram. The hot to the cold. Energy always move from hotter to the colder, higher to the lower. Clear now? The lower kinetic energy of particles, and look at this one diagram. The temperature of the gas increases when energy is added to a gas. So this is the topic of a temperature.